Hello, today I want to show you this small voltage booster that can have an output of around 500 volts with an input of only 3 volts. This is the diagram. We need a power supply, of course, a MOSFET, this diode that is optional. You need the diode if you want DC at the output. Without the diode you will get AC. A resistor and this little transformer that we will see how to build. This is an oscillator that works in the following way. The current from the power supply enters here at the center tap of the primary and through the resistor to the gate of the MOSFET. Then the MOSFET conducts and the current also flows here and then to the negative of the power supply. A magnetic field will be generated in the primary that induces a voltage on the secondary. The secondary voltage will be much higher than that voltage of the primary because we have a larger number of turns here. Next, the magnetic field in the primary also induces a current in this section of the primary that opposes the original voltage, and then we will have 0 voltage at the gate and the MOSFET is turned off. Then the cycle repeats again and again at several kilohertz of frequency. In order to make the output transformer, we need an inductor like this. It looks like a transformer, but it actually is an inductor. It has only one coil. We will convert it into a transformer by wounding a primary around the existing coil. We can obtain the inductor from a fluorescent lamp like this. After you cut the base, you can see the internal circuit, and here it is the inductor that we need. It also has some other useful components, such as some high voltage capacitors and power transistors. We need an inductor that has enough space between the coil and the core in order to wind the primary. Some circuits have inductors that do not have enough space, so this is not useful. This other has an inductor that we can use because it has enough space between the coil and the core. In order to wind the primary, take some magnet wire. Size 26 AWG is good for this, and 1 meter is enough. Insert the wire in the inductor and wind 6 turns first. After you wind the first 6 turns, take the wire and bend it like this in order to form a center tap, and then continue to wind in the same direction another 8 to 12 turns. The exact number of turns depends on the particular inductor, so you have to make some tests in order to find the number of turns that will give you the higher output of voltage. The transformer is finished. I used 6 plus 10 turns. It is important to identify the wires. In my case, the short wire corresponds to the 6 turns and the longer one corresponds to the 10 turns. Now let's see how to make the connections. It is important to identify the internal coil of the transformer. These normally have 4 pins, but only 2 of them are connected to the coil. You can use a multimeter to check the resistance, and the pins with around 5 ohms resistance will be the ones that are connected to the coil. Let's see the connections. These 2 points are the original coil of the inductor. One of them, it can be anyone, is the negative high voltage output, and the other is the positive output. You need to add a diode with the positive here and negative here. If you do not use a diode, you will obtain AC voltage at the output. For the remaining connections, I am using a MOSFET, an IRF-C44. Remember that the pins are gate, drain and source. At the gate we need to add a resistor 180 ohms. The other side of the resistor goes to our primary, to the side with 6 turns. The drain goes connected to the other side of the primary, the side with 10 turns, and the source goes to the negative of the input voltage. The center tap of our primary goes to the positive of our power supply. Let's now test the circuit. It is connected to the power supply and the output to the multimeter to check how much voltage are we obtaining. So let me turn on at 1.5 volts. We get 32 volts at the output. Now let me raise the voltage to 1.7 and we get 60 volts. Now at 2 volts we get nearly 200 volts, and let me put 2.5 volts and we get 400 volts at the output. Let me increase. At 2.8 we get more than 500 volts. I'm going to turn it down because the coil of the inductor is not designed for more than 500 volts and we can fry the coil. Another thing is that this circuit is good for up to 5 volts at the input. Otherwise, if you use a higher voltage, you may fry the MOSFET, assuming that your inductor can withstand the output voltage that will be around 1000 volts. Let's try to turn on this fluorescent tube. These tubes need around 800 to 1000 volts to turn on. Our circuit cannot give that voltage, but since the circuit can have an output of AC, we can use a voltage multiplier. Here I have a voltage doubler, so we will obtain from the 500 volts of the circuit around 1000 volts at the lamp. Here you can see that I am using the output of the circuit, but I am not using the diode. This is because I need AC for the multiplier to work. So let me turn on the power supply, and there you have it. The lamp is on. Of course, it is not working at full power because our circuit can only give around 2 to 4 watts maximum. Here I assembled the circuit again. As you can see, it's very small.